All right, so we have number 4 here, which is a different version of our velocity equation. So this is an average speed problem. So with average speed, we're still looking at distance and displacement and time, but in this case I have a time frame. So I'm trying to find an average between a time frame whenever I'm solving an average speed or velocity problem. So a track coach does split times for his all-star runner. It's the 20-meter mark at 2.8 seconds and the 40-meter mark at 5.7 seconds. What is the average speed of the runner? So I'm going to write out my givens first. So what do I have in this problem? So I have 20 meters at 2.8 seconds, 40 meters at 5.7 seconds. So I have two numbers that represent a distance. They both have the meters unit, that's the unit for distance, and two numbers that represent time, since they have seconds for the unit. So I'm going to break these up even further, designate them as finals and initials. So if I hit start on a stopwatch, which time number would come first? So 2.8 seconds would come first. So this is an initial time. So TI, the subscript I, can stand for an initial, a starting, is 2.80 seconds. And however far I was, my distance at that time is going to be my initial starting distance. So DI is equal to 20.0 meters. Now this problem has an endpoint. So 5.7 seconds is a final, is an ending. So I can put TF equals 5.70 seconds. And at that point in time, I was at 40 meters. So that is going to be my final distance, 50.0 meters. Unknown, what am I looking for? So my unknown is average speed. So I'm going to use the subscript AV to represent average speed. V there is for speed and velocity. My equation, so average speed is D final minus D initial over T final minus T initial. So in the sub step, I'm going to sub in these numbers that I found. So starting off with the final distance. So we ended at 40.0 meters minus the initial distance, which was 20.0 meters, over my final time, so 5.70 seconds, minus my initial time, 2.80 seconds. Now I can subtract what's on the top here, so I can get 20 meters that way. Subtract what's on the bottom, to get 2.9 seconds. And then I can divide to figure out what my average is. So when I do that, I get 6.896 meters per second. And don't forget, these answers are on the top here in no order. And so boom, we got that. So answer with symbol and unit. So average speed symbol. And then I can round this up here to 3 sig figs in my problem. So 6.90, and then the unit for speed, looking at my notes, that's meters per second. So let me know if you still have any questions, those of you that are absent and watching this. I know I didn't do a walkthrough of the notes, but try reading through the notes. There's a couple practice problems on there, so try doing the practice problem at home. So following the same steps listed at the notes that the notes have. Now you have 2 more under your belt, so go ahead and give 1 and 3 a shot here. At the very least, if you can do 1 through 4, then you're all set. I know 5 and 6 are a little bit tougher. These have conversions, so you have units that aren't given in meters per second, or seconds. So we're going to use our conversion factors or our metric chart to convert those units so that they're all in meters per second, or seconds for solving. Have a nice day, everybody.